When you hear the word asteroid, chances are you picture a massive rock hurtling toward Earth, cities exploding, oceans boiling, and humanity scrambling to survive. Movies love that idea, and a giant space rock shows up, everyone panics, and the fate of the planet hangs by a thread. But here's the real question. How dangerous are asteroids actually? Are we constantly on the brink of extinction, or has Hollywood been selling us a very exaggerated version of reality? The truth is more interesting and a lot less dramatic than the movies suggest. First, let's get one thing straight. Asteroids are real. They're not science fiction props, and they're not rare. Our solar system is filled with them. Millions of rocky objects orbit the sun, mostly concentrated in what's called the asteroid belt, located between Mars and Jupiter. Most asteroids are small. Many are no bigger than a house. Some are the size of a car. Others are closer to small mountains, and a tiny handful, a very tiny handful, are truly massive. The important thing to understand is scale. Hollywood usually shows us asteroids that are kilometers wide, moving impossibly fast, and appearing out of nowhere with almost no warning. In reality, that combination is extraordinarily rare. So let's talk about how often asteroids actually hit Earth. Small asteroids enter Earth's atmosphere all the time. Every single day, bits of a space rock burn up as meteors. You've probably seen one as a shooting star. These objects usually disintegrate high above the ground and pose no danger at all. Slightly larger asteroids, maybe the size of a small car, might survive the atmosphere and explode in the air. When that happens, it could be loud and dramatic, but still relatively harmless on a global scale. The most famous example of this is the Chelyabinsk event in 2013, when a small asteroid exploded over Russia. Windows shattered, people were startled, and some were injured by flying glass. But the asteroid itself never reached the ground, and it caused no long-term damage. Now let's scale up. Asteroids large enough to cause serious regional damage, something like flattening a city, are much rarer. These events might happen once every several thousand years. Asteroids large enough to cause global effects, like climate disruption, are rarer still. We're talking about events separated by tens of millions of years. The dinosaur-killing asteroid, for example, struck Earth about 66 million years ago. That impact was enormous. It changed the climate, reshaped life on Earth, and wiped out a huge number of species. But here's what Hollywood usually leaves out. That kind of asteroid is not sneaking up on us tomorrow. Modern astronomy has fundamentally changed the asteroid threat picture. Today, we actively track near-Earth objects. Telescopes around the world and in space constantly scan the sky, looking for asteroids whose orbits bring them closer to Earth. We already know about the vast majority of large asteroids that could pose a global threat, and none of them are on a collision course with Earth anytime soon. When scientists talk about potentially hazardous asteroids, that phrase sounds scary, but it mostly refers to size and orbital proximity, not imminent danger. An asteroid can be labeled potentially hazardous even if its closest approach is millions of miles away. Another misconception is speed. Movies often show asteroids racing toward Earth at unbelievable velocities, giving humanity only days or hours to respond. In reality, asteroid orbits are predictable. Their paths are governed by gravity, and once we observe them long enough, their future positions can be calculated decades or even centuries in advance. That means if a truly dangerous asteroid were discovered, we would almost certainly have years of warning, and years make a huge difference. With enough warning time, deflection becomes possible. We're not talking about blowing asteroids up with nuclear weapons like in the movies. That's risky and unnecessary. Instead, even a small nudge applied early enough can change an asteroid's path so it completely misses Earth. In fact, we already tested this. In 2022, NASA deliberately crashed a spacecraft into a small asteroid to slightly alter its orbit. The experiment worked. The asteroid's path changed exactly as predicted. That was a real-world demonstration that planetary defense isn't science fiction anymore. So why do asteroid movies feel so convincing? Because they tap into something very human: fear of sudden, unstoppable disasters. Asteroids are simple villains. They don't have motives, they don't negotiate, they just arrive. But reality is slower, quieter, and far more manageable. Asteroids are not an immediate threat hanging over our heads. They are a long-term, low-probability risk, one that we understand better every year. That doesn't mean we should ignore them. It means we should take them seriously, calmly, and scientifically. The real danger isn't that an asteroid will wipe us out tomorrow. The real danger would be ignoring the sky entirely. Fortunately, that's not what we're doing. So the next time you see a movie where an asteroid appears out of nowhere and humanity has 72 hours to survive, remember this: the universe is dangerous, but it's not reckless. And for asteroids, knowledge is our greatest shield.